Okay, with this brief video, I wanted to make one point I forgot to make earlier. So shown here is a ripple carry adder of n bits, ripple carry adder. And you can see in each bit position here, I've got a full adder. And the full adder circuit is also shown below here. So by replicating the full adder in each bit position, I can make an n-bit adder circuit. Well, here in the least significant bit position, I don't really need a full adder because if I'm adding two, let's say 8-bit or 16-bit numbers together, I know the carry in is going to be tied to ground for the carry into the least significant bit. And so if I tie this signal to ground here, I can come up with a simpler circuit for just the least significant bit. If I analyze this circuit here by tying C into ground, well, if one side of an XOR gate is tied to ground, then it's like the XOR gate isn't even there, and it's just the signal from the other input is going to pass right through. The XOR function A, B, Y looks like this. And so let's say that this was Cn here. Here's the output of the XOR function. If A is tied to Cn then, and A is always ground, I'm in these two upper rows here, and you can see that Y, it just follows B directly. So if I tie one side of an XOR gate to ground, the output is simply the other input. So I can just show, the output S is being tied directly to the A XOR B gate. Likewise, if this input is tied to ground, then one side of this AND gate is tied to ground, and so that output is always 0, the output of that AND gate that goes to the OR gate. And if the output of the AND gate is always 0 and one side of the OR gate is always 0, I don't need the OR gate either, because the output of the OR gate will always just be the other side, so that can be C out as well. And that means for the least significant bit, where I've tied C in to ground, I can have a simpler circuit that simply has an XOR gate, A, B, to form the S output, and an AND gate to form the carry out output. So clearly that circuit is simpler than the original circuit, and I arrived at that circuit simply by tying the carry in input to ground and analyzing what would happen to the other circuit gates and realizing I could come up with a simpler circuit. Well, this simpler circuit is called a half adder, or just HA, I guess, for short. And a half adder can always be used in the LSB, the least significant bit position of a ripple carry adder. Everywhere else still needs a full adder because everybody else can have a carry in. But in the case of the half adder, in the case of the least significant bit pair of a ripple carry adder, we know that carry in will be tied to ground, and therefore we can use a half adder circuit in that position.